Welcome to the Equip session on securing your web and mobile applications with voice biometrics. As he just pointed out, my name is Noel Grover. I'm the CEO of VoiceIT Technologies, an initial founder. I'm here today to introduce you to voice biometrics and how it can be used to secure your web and mobile applications. I welcome all of you after this session to please come visit us at our booth. If you have any questions, we'll be more than happy to answer those questions and help you maximize your security needs. So let's get started. So before we get into the science of voice biometrics, let's stop and think about what inspired voice recognition. And for me, it was Star Trek. As a little boy, I watched and thought, wow, how cool is it and amazing that Captain Kirk is talking to a machine and it's listening and doing what he asks. I didn't even know what a computer was, and I sure in the heck didn't understand how impossible at the time voice recognition or voice biometrics was to accomplish. Yet it inspired me, it made me curious with computers, and more specifically with voice recognition at a very early age. So let's take a look at Captain Kirk and how it inspired myself.
Photograph Meridian. Now photograph both.
Sorry, not my technical difficulties. So, you just heard Captain Kirk, and he was talking to a computer, and I thought, again, how amazing was that? It was pretty cool, all the way back in 1966. So let's take a look at the science behind voice biometrics. To start, let's talk about the basics of human speech. The most important part of human speech is the frequencies produced. And what is a frequency? Simply put, it's the number of times that something happens during a particular time period. In speech processing, we measure frequencies in hertz. Most adult men normally speak between 80 and 160 or 180 hertz, while most adult women speak between 165 and 255 hertz. However, the majority of energy that's produced is concentrated between 300 and 3,000 hertz. The following image shows a male voice saying, "Never forget tomorrow is a new day." Notice the blue rectangle. It shows a frequency range between 300 and 3,000 hertz. Now, let's take a look at the sound data more closely. There are different ways to represent large amounts of data with smaller data sets. In speech processing, we call this linear predictive coding, or LPC. It is a tool used in audio signal processing for representing the spectral envelope of a digital signal of speech in compressed form. Okay, that's a big, mouthful right there. So what the heck does this really mean? Well, simply put, the best way to understand LPC is to look at the image below and compare the two colored lines. The red line represents the original signal frequency spectrum in a point of time, while the blue line represents the LPC spectrum at the same point in time. If you were to pull on these two lines, you would see that the blue line is much, much shorter than the red line. Thus, a smaller data set to use and analyze for speech processing purposes. Without doing this type of compression, our computers would not be able to process the large amounts of data in order to produce the results in that a small amount of time. So, how do we put it all together to create a voice print? We use the data from the LPC spectrum, from the frequency spectrum, which we just talked about. Let's play the original sound file. You will see the original sound file in green and the signal frequency spectrum in red. Never forget, tomorrow is a new day. Hey, I'm sorry about that. It wasn't me. So again, you just saw in green here, you just saw the original sound file, and then you saw the red line squiggling up and down, but it showed you the different frequencies that were being produced as it was being played. To recap, you just saw the signal frequency spectrum change in red as the frequency changed in the original sound file. So if we were to take this LPC of the signal frequency spectrum we just talked about in that last slide and store this data, we then can take that data and compare it to different frequencies of the voice print for future voice prints. So basically, what does that mean? It means we take this linear predictive coding, and we take the frequencies from that, and we store that for an enrollment, and then later on, when you authenticate, we do the same process, and we can do the compares. And that basically is what makes up a voice print. I will now switch to a terminal window and demo how we do web development using Python calls. I will create a new user. I will then also enroll a new user, and then I will also authenticate a new user. So I'm going to go ahead and bring up the terminal window. And as you can see here, get my mouse over here. So I'm in my console window now, and one of the nice things about VoiceIT is we have this very simple API. It's basically 10 API calls, but what we also have done is we've created wrappers. And these wrappers allow you as a Python developer, in this case, to more easily create these calls and use these calls. So that's what I'm going to show you here right now. So the first thing that we're going to do is initialize the library. So after you've downloaded the Python library, installed it, you just go ahead and initialize it. And then the next thing you do is you create the class, initialize the class. In this case, I initialize it with a developer ID of 111111. And again, when you utilize our APIs and you sign up for our services, you have a unique developer ID. For these demonstration purposes, I'm using 11111. So I'm going to go ahead and initialize the library. So the first thing we got to do, of course, is create a user. So to do that in Python, we just basically go in here and we create the user. And in this case, you can see some parameters there. It's just basically identifying who the user is with some information. Again, this information doesn't have to be tied directly to the user. It could be some information that is on your backend system that would identify that user. So it doesn't have to actually identify the user who they are. It just has to identify in your system who that user is. So I'm going to go ahead and do the call. And as you can see, it actually comes back with a JSON response. Oops, sorry about that. I guess I can't really highlight while I am holding the mic here, so I apologize. But basically, it comes back with a JSON response that says that the result was successful. So it successfully created that user in the system. So the next thing we got to do is do the enrollments. And what I'm going to do is I'm going to play the enrollments for you so you can hear them. So right here you can see here's an enrollment for Never Forget Tomorrow's a New Day. Never forget, tomorrow is a new day. Okay, so that was the enrollment. I'm not going to play all of them, but I will play the authentication as well. Never forget, tomorrow is a new day. So again, these were all separately recorded, and they're just saved here on my system right now. So what I'm going to do is go back to the terminal window, and I'm actually going to go in here and enroll the first one. So what this is doing, again, is taking that WAV file, pushing it up to the server, because we already created a user, and enrolling that user. So again, it comes back with a JSON response, and it says that it was a successful response. It gives you an enrollment ID. And then another thing that's separate from voice biometrics is we're providing some speech-to-text responses as well. So basically, we're saying, what did that person say? And then how confident did that person say that? So this would help you in your business decision or business rules when you're actually doing the enrollments. You can choose to say, hey, you know what, I maybe want to throw out an enrollment that isn't at least 50% confident in what you want them to say. So it's a tool that lets you, eliminate enrollments or keep enrollments based upon that information. So I'm going to quickly enroll 2 more times. Again, it's sending up the WAV file to the server, and again, it comes back with a JSON response. And I'm going to do the 3rd one. In our system, you actually have to have a minimum of 3 enrollments. In fact, the system won't allow you to do an authentication call unless you have 3 enrollments in the system. So again, that one has successfully done it. So now, the next step and final step in this particular demo is just showing you, I'm going to do an actual authentication call. So here's an authentication call, again, identifying the user, some parameters on saying what confidence I want, and of course, the actual enrollment, or sorry, sound file that was recorded for the authentication. So I'm going to go ahead and do that. Again, it's sending that WAV file up for processing, and it came back with a JSON response. Again, you can see that the call was successful, the authentication was successful, it was a 92% confidence, it gave the enrollment that it matched to, and then again, it still provides that text-to-speech, or sorry, speech-to-text of what was said and the confidence in that as well. So again, that information can be parsed and then displayed if you wish to have it displayed in your UI. So that's it for that particular demo. I'm going to go back to the slideshow here. At this time, I'd like to introduce you to Armand for our mobile demo of voice recognition. And it's a great out-of-the-box experience that he's created, and he's part of our development team. And so, Armand, take it away.
Yeah. Thanks, Noel. Well, thanks, Noel. Your Python demonstration was awesome. And okay, so let's go for this. Let me just exit out. And wow. My mouse. Okay. So my phone is ready. It's all cool. Okay. So Noel just showed you a demonstration of using VoiceIT and integrating it using Python. But over the last few months, I've been working on building a super easy and simple out-of-the-box solution to integrate VoiceIT into your mobile apps. And now, all you need to really do is add our SDK, drop it into your project, and use 1 line of code. For example, this is 1 line of code in Swift, Apple's new programming language. And you can pass in a few parameters, such as a unique user token, a suggested voice print phrase, the developer ID, and a confidence level for how confident you would like the authentication enrollment to be. And so let's just show you a demonstration of what we've got. So here is a mobile phone. Here's an iPhone 6 that I've got with 2 apps loaded onto it. One is our VoiceIT app, and the other one is a demo app that we've created just for this demo. And oh, it says login failed. Just gonna start it up again. And so now you can pass in a user token, and let me just separate this over here. Put our 1 line of code over here. So this login now button that you see on the screen is actually going to take a unique user token. So in this case, let's see, Armand at Signal. And it'll pass that unique user token to the 1 line of to this code, and so instead of Armand, that would be Armand at Signal. It'll give all these, the demo app already has all these parameters set, and so now when I click login now, it should open up the VoiceIT app. And I'm going to go ahead and click that. And it opens up the VoiceIT app where I'm going to probably put away the mic and do the enrollments and authentication. sound is... Sorry about that. Let me just make sure this is headphones. Oh, well... Hey, oh, sorry about that. For some reason, our sound didn't seem to work. But if you log in now, go into our app, it should have some sound for you. That's okay. So this right now is telling never. Wow. It sucks. I think I'm actually going to just demo this on our simulator because sound seems to work on that, and for some reason, we're having lots of tech difficulties today. And so let's just show you the same exact thing on our simulator. And so we go into the demo app. I type in Arman at Twilio, and we log in. We should have sound.
Please say your voice print phrase after the beep.
Never forget that tomorrow is a new day. There you go. And this is our first
Please say
enrollment.
your voice
We
print
successfully
phrase
passed to our servers.
after the beep.
Never forget that tomorrow is a new day. And that's our second successful enrollment, hopefully. Come on. And
Please
third
say your
enrollment
voice
now.
print phrase after the beep.
Never forget that tomorrow is a new day. And that's our third successful enrollment. And now it's going to finally ask us for authentication. Never forget that tomorrow is a new day. And upon a successful authentication, it should take you back to the developer's app with a JSON response of login success, and then we could display that there. And so basically, this out-of-the-box solution can be used by adding one line of code and an SDK inside of your project. And you don't even need to build the UI. You can just add this to your app and start adding voice authentication just like that. And now I'm going to hand it back to Noel. Thank you, everybody.
Thank you, Arman. I appreciate that demonstration. So I'm going to switch back to the presentation. So anyways, you got to see how easy it was. So again, you drop one file into your iOS application, you write one line of code, and the VoiceIT app has encapsulated the creation of the user, the enrollment of the user, and the authentication. So if Arman spent some more time and went back into the app with that same user token, it would have just asked him to authenticate. So it's a way for you to easily integrate at any point in time in your iOS app a voice authentication. So before we wrap things up I'd like to talk about spoofing. A great film that helped the awareness of voice biometrics a long time ago was Phil Adelson's Sneakers. And in this clip, you will see an example of spoofing.
Hi, my name is Winifred.
Hi, my name is Werner Brandis. My voice is my passport verified.
Okay, so I don't know, any of you raise your hands who've seen that movie? Okay, good. I didn't date myself too much here. Okay, great. So here you saw Robert Redford spoofing access to a secure area, and they did that by splicing the man's voice together to produce that recording and then get in So the question is how does VoiceIT prevent this from happening? And for that, I would like to introduce you to Billy and Max. They're going to demo our anti-spoofing technology. One of the things that, come on up. One of the things that is how this is done is we actually have a Twilio plus VoiceIT application. And what this is going to do, again, is going to show our anti-spoofing technology. Billy is going to do enrollment and authentication, and then Max is going to try to spoof them. So here you go.
All right, hello guys, I'm Billy.
And I'm Max, and we're account project managers with VoiceIT. So like Noel said, what we're going to do is Billy is going to use the VoiceIT Twilio IVR to authenticate, and I am going to try and spoof it with a recording of his voice, kind of like in Sneakers. So without any delay, let's get to it.
You have called voice authentication. Your phone number has been recognized. You can now log in or press 1 now to enroll for the first time. Say the following phrase to authenticate. Never forget tomorrow is a new day.
Never forget tomorrow's a new day.
Authentication failed. Voice phrase was not recognized.
So as you can see, the noise is a little loud here. I'm going to try again and see how it works this time.
You have called voice authentication. Your phone number has been recognized. You can now log in or press 1 now to enroll for the first time. Say the following phrase to authenticate. Never forget tomorrow is a new day. Your authentication did not pass. Please try again. Please say the following phrase to authenticate. Never forget tomorrow is a new day.
Never forget tomorrow's a new day.
Authentication failed. Voice phrase was not recognized.
All right. Based on our data, the Twilio set up the confidence level at 89%, which is really high. So based on our data, it might occur some false negatives. Let's try it one more time. Hope this time it works.
You have called voice authentication. Your phone number has been recognized. You can now log in. Press 1 now to enroll for the first time. Please say the following phrase to authenticate. Never forget tomorrow is a new day.
Never forget tomorrow's a new day.
Your authentication did not pass. Please try again. Please say the following phrase to authenticate. Never forget tomorrow is a new day.
Never forget tomorrow's a new day.
Authentication failed. Voice phrase was missed.
Yeah. Well, in ideal conditions, this works a lot better, and you can try the IVR demo for yourself when it's not in a crowded convention center and see how well it works. But we're going to try and demonstrate the spoofing. So I know I wasn't too sneaky, but I did record some of Billy's authentications. So now I'm going to try and get it into the system, like in Sneakers.
You have called voice authentication. Your phone number has been recognized. You can now log in or press 1 now to enroll for the first time. Please say the following phrase to authenticate. Never forget tomorrow is a new day.
Never forget tomorrow's a new day.
Authentication authentication failed. Voice print phrase was not recognized.
So, as you can see, even though the recording I had was much better than the one in Sneakers, I still couldn't get into the Twilio IVR system. So this is a very powerful anti-spoofing technology we've implemented.
Right, so his recording is actually based on one of the successful authentication we did before. And actually, we can actually make the spoofing even harder for Max by using other languages to enroll. Like my first language is Chinese. I could use Chinese to enroll and authenticate. So Max cannot learn the language that quickly.
Yeah, we've tested it in a bunch of languages, and no matter what language you use, we'll be able to authenticate you. So I think that's about all we have time for. So thank you, everybody, and we're going to hand it back to Noel.
Okay, that worked every time before this, by the way. I just want to let you know. And we never tried it with this port plugged in there, so I don't even know if the sound was actually going in there. So what I do is I welcome all of you to use this. It's available for you guys as well. It's 612-400-7423. So again, if you guys want to try that, you can try that at any time. It's not a it's a public number, and it's actually a Twilio number. So, to recap, we basically have created a series of APIs that allow you to create a user, enroll a user, authenticate a user. We've created wrappers that allow you to use your programming language of choice to accomplish that. You've also seen a beta version of our out-of-the-box experience, which, by the way, was using the same system as the Python and the out-of-the-box experience that Armand just demonstrated to you. So you got to see that as a way to easily take one line of code and do that as well. And so we're going to keep on coming up with more and more ways to make this easier for you developers to be able to take this platform and integrate it into your IVR systems, your web, and your mobile applications. So at this time, I would like to invite you guys for any questions to come see us again at the booth, and we'll help you with anything that you have for your security needs. And that's it. Thank you so much.